In this video, I want to have a look at the gradient. So the gradient of a line or an interval tells us about how steep it is. So the gradient compares the vertical rise to the horizontal run. If we look at these two diagrams, positive gradient is when a line or an interval moves up to the right, and a negative gradient is when it moves up to the left. So we can tell whether it's going to be positive or negative just by looking at it. To actually calculate the gradient though, what we're going to do, like it says up here, is to compare the rise to the run. So that means when you're moving from one point to another, we're comparing how far up we had to move to how far across we had to move. So if we did this one, moving from one point to the other, we're moving the vertical change to the horizontal change. So to find those distances, it's rise over run, or the more mathematical way of figuring it out is if we had 2 points. So if this was x1, y1, and this was x2, y2, then our gradient can be calculated, so little m for gradient, by going y2 minus y1, that finds this distance here, and then x2 minus x1, which finds that horizontal distance there. So we're comparing our rise over run. So I want to have a look at an example. We're asked to find the gradient of the interval joining the points 4, minus 1 and 10, 6. So we've got our little formula down here. Let's just call them x1, y1 and x2, y2. Again, we could have done them the other way. As long as we're consistent, it doesn't matter. So our gradient, which is a lowercase m, is y2 minus y1. So we have 6 minus 1 over x2 minus x1, so 10 minus 4. So 6 minus 1 would give us 7, and 10 minus 4 would give us 6. So we'd have a gradient of 7 over 6. So that means it's positive, and for every 7 units we move up, we move 6 across. We could rewrite that as 1 and 1/6, but usually improper fractions are a little bit nicer to work with if we're then going to use it in a calculation later. So we'll leave it as that for now.